What are the default hello and hold times for HSRP? Well, let's take a look at it. On DSW1, we'll type in the command show standby for VLAN 10, and we'll see that the default hello and hold times are 3 seconds and 10 seconds. We can change these timers if we want to. We may feel in our organization that a 10-second failover time is too long. It's too long. We end up dropping communications for certain applications when it's set to 10 seconds. So as a result, we can lower the hold time. We can lower the hello time. And our goal or the recommendation is to keep the hold time at 3 times the hello time or greater. So by default, it's not even 3 times the hello time, the hold time. It's 3 and a bit. Because 3 times 3 would be 9, but the hold time's set to 10. It's not going to force you to do 3 times the hello time for the hold time, so be mindful that that is a recommended practice to have the hold time 3 times the hello time. So how can we modify the timers? Well, we can modify the timers by changing it for the group. So we type in global configuration mode, configure terminal, interface VLAN 10, standby group 10, and there's our option timers. Notice we can either specify the hello time in seconds or milliseconds. So if we need aggressive timers for aggressive failover, we can do so. So let's say we type in milliseconds, 200 milliseconds. And then it wants the hold time in seconds or milliseconds. So let's say milliseconds and 3 times the hello time. So 600 milliseconds is what we're going to use in this particular example. So we've just changed our timers. It is recommended that you make sure they are consistent across all devices in the same group, because you could end up with HSRP flapping, whereby DSW1 thinks it's active, and then all of a sudden it's missing the hello packet, and then it's not active anymore, then it's active, then it's not active. So we want to make sure that the timers are as accurate as possible and consistent as possible throughout the environment. Now, just because you can get aggressive with your timers doesn't mean you want to do so. Notice the hello time could have been set to 15 milliseconds and the hold time to 50 milliseconds. That's pretty fast failover. However, if you have congestion in your environment, is it possible that a hello packet will be dropped before this timer expires? If your hold time's 50 milliseconds, you better get a hello packet there within 50 milliseconds. What if they get dropped by accident or because of congestion? Then all of a sudden, the standby device thinks it's active, so it goes active. Then it receives the hello packet late and goes back to being standby. Then it's active, then it's standby. It keeps flapping because the timers are too aggressive for that environment. So be careful. Just because you can do it doesn't mean you want to do it. Not only that, keep in mind that you want to take into consideration what is happening elsewhere in your network. Meaning, take into consideration how long it takes spanning tree protocol to fail over. How long does it take for your interior gateway protocols? Let's say you're running EIGRP. How long does it take EIGRP to fully fail over? Because if we're looking at DSW1 and DSW2, they have uplinks over to R1. They are routing up those links. Well, how long does it take that IGP, EIGRP, to fully converge? If DSW2 can become the active forwarder for VLAN 10 in 200 milliseconds, let's say, is that too quick? Meaning that traffic gets to DSW2 and it's being dropped anyways? If that's the case, let's tune our timers to be consistent in our environment. That way there, when a failover occurs, we reduce the chance of traffic being black-holed, traffic being dropped. So let's try and have consistency with timers amongst all the various services that we're having. So we want to make sure that failover doesn't happen too fast, but we don't want it to be too slow either. So think about all the other convergence delays that are happening within the environment. Also, we don't necessarily want the device to become active too fast. For example, we could set up a preemption delay timer. So think of this scenario here. We have a router that reboots. That router reboots. It was currently the active forwarder. So now it's no longer the active forwarder, the standby is. It reboots and comes back up. HSRP is up and running. But the IGPs haven't converged yet. So the router still doesn't fully have what it needs to route traffic yet. Now it's the forwarder, and users can no longer connect to the network until everything else converges upstream. So why preempt that fast? Meaning, why take over the active forwarding role that fast? Let's hold back just a bit by setting the preempt delay timer to a value that is 150% of the boot time. So what does this mean? It means you will determine how long it takes that device to boot. Once you figure out that time, let's say it is 3 minutes exactly to boot. You then add another 50% to that time. So if it's 3 minutes to boot, 50% of that would be 1.5 minutes. Now we're looking at a total time of 4.5 minutes. That's your preempt delay time. 4.5 minutes. That gives the device the chance to fully converge everything else it needs to converge, and then become the active forwarder, preventing traffic from being dropped unnecessarily in the environment because it became the active forwarder too quick. So that's the preempt delay time.